Good morning, students. Today we are going to see about what is half-wave rectifier. So, half-wave rectifier is something that it is a AC to DC converter. It is something that which converts AC voltage or current into DC voltage or current with the help of a PN junction diode. And with this diagram, can clearly explain if there is any the person is running towards the circuit and only the half wave has been rectified and passed through it. And next thing is that we are going to see about what is half wave rectifier and its working principle, and also the formulas for efficiency, ripple factor, and RMS value, and the form factor with the help of applications and also disadvantages. So here the half-wave rectifier is the simplest AC to DC converter, which construction is something that it has one diode and one transformer and also one load resistance. And in this diagram, the AC input, which is an alternative current, which is entering to the rectifier, and it allows the current flow in only in one directions. So and also it provides the resistance from the current flow. So altogether that is has been rectified and it's given the half wave form. And let us see the half wave circuit. So here the half wave circuit is that something that it has one diode and one transformer and also one load resistance. So there is no fancy bridge or no center tapped where AC comes knocking at the door and it opens to for the positive half cycle, and negative half cycle has been closed. So in this diagram, it's clearly represent that the transformer and the diode and the load resistance. So when we give a supply, the transformer is something that step down transformer where higher voltage has been converted to the lower voltage and is given to the diode. Here the diode acts as a PN junction diode where it conducts current only in the forward bias conditions. So see this diagram, when the high AC voltage is applied to the primary side of the step down transformer, so the secondary side is obtained a low voltage and it is applied to the diode. So here the diode is a forward bias during the positive half cycle, and reverse bias, the negative cycle, has been eradicated. So this is a basic function of the half wave rectifier. And also for better understanding, let us see the half wave circuit by replacing a secondary transformer coil into a voltage source. So here the secondary transformer has been replaced by a voltage source which is connected to the diode and the load resistance. So for the positive half cycle of the AC voltage source, the circuit efficiently becomes, and also it generates a positive half cycle. Next, so when the diode is forward bias, it acts as a closed switch. So but during the negative half cycle, the AC voltage is the equivalent circuit becomes as shown in the figure, that is it is an open switch. So here when the diode is in reverse bias, so it acts as an open switch, so there is no current flow occurs to the load. The output voltage is equal to 0. And this is the half wave rectifier waveform. So here the waveform is before and after rectification. So the first waveform is before rectification, and after applying to the half wave rectifier, this positive half cycle is been obtained. Next is a half wave rectifier capacitor filter. Here the output waveform of the half wave rectifier is a pulsating DC which has some ripples or some noise distortion. In order to eradicate it, we use a capacitor to filter the ripples and produce an efficient waveform. Okay, and next is let us see the application of half wave rectifier. Here there are few common application of half wave rectifier that is something that signal demodulation purpose. It is mainly used for signal demodulation purpose, and it is used for rectification application, and also it is used for signal peak application. And the main disadvantage of the half wave rectifier is power loss and low voltage, and the output can contain a lot of ripples. It can be eradicated with the help of capacitor, even though it has some ripples. So here the efficiency is around 40.6 maximum, and the ripple factor for this half wave rectifier is around 1.21, and the form factor is around 1.57. So here the value for calculating the load current is IRMS equal to IM by 2, and the form factor of the half wave rectifier is RMF value divided by average value. So the form factor for this half wave rectifier is around 1.57, and also let us see the half wave rectifier formula for ripple factor. The ripple factor is calculated by root square of Vrms divided by VDC or the whole square minus 1, and this is the formula for calculating the efficiency, that is uh, power in the DC divided by the power in the AC. This is the efficiency formula for calculation, and the output ripple frequency is around 50 Hertz, and also the ripple factor is around 1.21. The efficiency of the half wave rectifier is around 40, and let us see the summary. We saw what is half wave rectifier, its definition and its circuit components. What are the three basic components is diode and transformer, and also a load resistance, and working principle, how the half wave is generated, what is filters and its application and disadvantages. I hope you all understood about this session well. If you have any clarification related to this topic, please feel free to contact. And the quiz, let us go to the quiz session. A diode in half wave rectifier conducts during positive half cycle, negative half cycle, or both half cycle and none. The answer is only positive half cycle. Next is that you have a small sensor circuit with 5 DC, but your supply is 9 volt. You want a simple rectification solution. Would you half wave rectifier be ideal, or why not? If an AC input in RMS value and the diode is ideal, calculate the average DC output. Okay. I hope just try to solve this. And what we also saw about the ripple factor and the efficiency. And if you have any clarification related to this topic, feel free to contact me. Thank you.